Good morning to one and all. My name is Divya Kumar, Assistant Professor from SNS College of Technology. In this video lecture series, we are going to discuss about and subject design of transmission systems. The topic is design of sprockets and chain drive. When we want positive power transmission without slip, belts are not always the best option. In applications like motorcycles, conveyors, and heavy industrial machineries, we use chain drives and sprockets. For power transmission, there are about different types, like we can use flat belt, V belt, gear drives, or else chain and sprocket. If we want a positive drive and also we are in need of no slip, we can go with the chain and sprockets. But how do we design a sprocket? And also how do we decide the number of teeth and how do we need to calculate the pitch diameter? For that there is an answer in this video. Before that we need to know what is a sprocket. A sprocket is a toothed wheel that messes with a chain to transmit the power from one shaft to the another. Unlike belts, there is no slip in the case of sprockets and chain drive, and the velocity ratio is exact and it is suitable mainly for medium and high power operations, which is majorly used in motorcycles, bicycles, conveyor systems, industrial machines, etc. The working principle of chain and sprocket is chain drive mainly works on the positive engagement principle. Each tooth of the sprocket fits into the chain rollers, so motion is transmitted without friction based slip. The formula behind the velocity ratio is n1 divided by n2, which is equal to t2 divided by t1, where n1 is the speed of the smallest sprocket, n2 is the speed of the largest sprocket, t2 is the number of teeth in the larger sprocket, and t1 is the number of teeth in the smaller sprocket. Next we will discuss about the design procedure. Before that, why proper sprocket design matters. In order to avoid the excessive wear, chain jumping, noise and vibration, reduced efficiency, energy losses and heat generation, etc. Our major design is to produce the or make the proper tooth profile, and also we need to select the optimum number of teeth, accurate pitch diameter for the smooth engagement of chain with the sprocket. These are all some of the design parameters which we need to consider while designing the chain and sprocket drive. We need to find out the number of teeth, tooth profile, pitch circle diameter, material selection, face width, chain pitch, determine the power and speed, etc. Next we will discuss about the design calculation one by one. First we need to determine the power and speed of the chain drives, where P is the power, speed N1 is the speed of the drive, and N2 is the required speed of drive 1. For that we have one formula, velocity ratio, which is equal to N1 divided by N2. Next we need to select the type of chain. Now there are about three different types of chains: roller chain, silent chain, leaf chain, etc. And the chain selection mainly depends upon the power capacity, speed, shock conditions, etc. Next we need to determine the number of teeth. Minimum number of teeth on smaller sprocket will be usually ranges from 17 to 25 teeth. Why? It is too small. In order to increase, it has an increased wear, polynomial action increases and the vibration increases. So we select the standard teeth number. Then we need to calculate the T2 based upon the velocity ratio by using the formula T2, which is equal to T1 into velocity ratio. And then we need to calculate the pitch circle diameter by using formula D, which is equal to P divided by sine 180 divided by T, where P is the pitch of the chain and T is the number of teeth. Next we need to determine the chain pull. For that we need to find the power transmission, P, which is equal to F into V, where F is the chain pull and V is the chain velocity. In order to determine the chain velocity, we already know the formula V, which is equal to pi dn divided by 60, where d is the diameter and n is the speed. Next we need to calculate the center distance. Recommended center distance varies from 30p to 50p, where p is the pitch circle diameter. Next we need to calculate the factor of safety based upon the braking load and the working load. Some of the major design parameters are chain pitch, number of teeth, pitch circle diameter, chain velocity, center distance, and lubrication condition, etc. The major advantages of sprocket drive is when we require no slip, we can opt for the chain and sprocket drive. And the efficiency is of about range of 95 to 98%, and it is suitable for harsh environments, compact and longer life. The applications of the chain drive are motorcycles, bicycles, conveyor systems, heavy machinery, agriculture equipment, etc. Sprocket design is a combination of chain selection, teeth selection, pitch diameter determination, and load checking. Because chain drive works on positive engagement principle, they provide exact velocity ratio slip without the slip. Thank you.